Hello, welcome to Scottish Developers. Thanks for joining us. And this is our first meetup of 2022. So I hope you've all had a good start to the year and are ready for the first of our many exciting sessions. So just before we get started, just to let you know that we can use the YouTube chat there in the comments, and also tweet hashtag Scottish Developers if you've got any comments, any questions for our speaker, and yeah, anything else if you want to say hello in between meetups as well. So I've got some comments here saying it's a bit quiet, so I'll speak a bit louder. Hopefully you all can hear me. I'll not be speaking for too long anyway. And just to let you know quickly about a few meetups that are going to be happening, our next two sessions. We have one on March 9th with Alistair about kind of image optimization for web and CDNs and all that fun stuff. That'll be really great. And on April 13th with Sarah about combining Azure and Octopus Deploy, which I'm personally really excited about because I use both of those things. So that will be really awesome. So go to Meetup and sign up for those. And also, if you have any suggestions or requests, or if you'd like to volunteer to give a talk, then please do let us know. Get in touch, and we'd love to have you speak with us. And today's session is with Ross, so I'll bring Ross in to say hello. If I can, well, I've lost control of my StreamYard. 2 seconds. Here you are. You should be with us now. Hi, Ross.
Hello. Are you able to hear me?
I can hear you. Hopefully you can hear me. I think some people had some sound issues earlier, but hopefully you can hear me.
All good. Yep.
Yeah, all the way from sunny Edinburgh. Am I right?
It just started raining as I got home, so I timed the commute perfectly today. So one of the rare days where there's some rain, but not too cold, so I can't complain too much.
Well, I'm the opposite, and I had a rare day where I managed to commute without rain. So I'll take that as a win here in Glasgow. And I'll let you introduce yourself.
Of course, yeah. So my name's Ross. I'm a software engineer with about 4 years professional experience behind me at this stage. Born and raised in Scotland, I'm currently working for Trustpilot, a service review platform, which I'll dive into a little more detail on within the hour. For the most part of my life, I've grown up in a town called Perth, just north of our capital city in Edinburgh. But I now live in Edinburgh and have done for the past 8 years, where I've studied and had a couple of jobs in engineering. So hello to everyone in Edinburgh and further afield joining me today.
Awesome. Well, I will just let you get started. I'll share your screen now. I'll stop sharing my screen, and I'll leave you to it. So if anyone's got any questions, put them in the chat, and I'll pop in and ask them to Ross if he doesn't see them. And yeah, over to you.
Awesome, thank you. Hopefully everyone can hear me loud and clear, but if there's any trouble with the sound or the slides, give me a shout and we'll see if we can get that fixed. So for the next hour, I'm going to be giving a talk on AWS step functions and specifically experiences orchestrating different requests at scale using this service. So I'm hoping to cater for all different ranges of experiences today, whether you're coming in entirely brand new to step functions, or whether you're coming in with experience already and perhaps there's a few new features or tricks that you'll learn today within the next hour. Of course, I will share some social media handles later on as well, so if there's any questions or any comments, feel free to reach out afterward or ask your questions during the session. I'll be happy to get in touch. I do quite often declare my passion for step functions, and quite recently on the Slack thread, I declared the love quite explicitly, and one of my colleagues insisted I share that in the introduction slide. So Taylor, if you're listening, this is for you, and as promised, first slide, just to prove that I am a big fan. A little bit more of a background of myself. I've already mentioned that I currently work for Trustpilot, but before that, I worked at a company called the People's Postcode Lottery, which is a lottery supporting charities in Scotland and the rest of the UK, with sister companies in mainland Europe as well. So in the past 4 years of professional experience in software development, the last 3 of those years have been extensively of AWS. And this is going to be a very AWS-centric presentation, but I'm sure there are other cloud platforms and other solutions available. My experience is predominantly here in AWS. And just to sort of back that up in my time learning the different services, I've got a few AWS certifications under my belt, including security one and some of the solutions architect certifications. The social media handles in the bottom left corner, I do share quite a few technical blog posts on Medium under the handle TR Roads, which quite often explore step functions, but also serverless more broadly, and occasionally touches on other topics too, if that is of interest. I'll point out some topics during the hour that I go into a bit more of a deep dive over for anyone that wants to read further into that. So what to expect within the hour? First and foremost, particularly for those coming in new to step functions, I'll cover what they are and why they may be useful to you at a high level. Then I'll dive into two use cases, both touching on experiences I've had in the past few years, and both largely based on real problems that myself and the teams I've worked in have had to solve. We'll touch on the different features and the different ways we approach those problems too. Toward the end, I'll touch on a brief comparison on the different types of step functions, the different modes. For the most part of this hour, I'm going to be focusing on what's called standard step functions. And up until a couple of years ago, that was the only version available. But more recently, a new mode has come in, which may be of interest. And I'll cover that toward the end. So ultimately, what are step functions? For anyone coming into this entirely new, step functions are the AWS answer to state machines. If you're looking to coordinate different services and make automated workflows, then step functions is a good contender or a good candidate to answer those problems for you. Typically, you have a start state and an end state, and a load of different states in between, where you can have branching and choices, repeated concurrency, lots of different features that we'll touch on shortly. When state machines may be useful to you, there's a few different cases. You may be building platforms that are coordinating with many, many different services, many microservices. You may be taking advantage of things like serverless functions, which are called Lambda in the AWS context, or other services like DynamoDB tables for NoSQL or queues. There's a whole range of different things that you can coordinate and tie together. And maybe you're looking to automate some particularly complex or long-running processes for your customers. These are the kind of cases where I would expect step functions to be considered, especially if you're working largely in the AWS ecosystem. And the benefits to step functions, up until about autumn last year, they supported 17 services, including the Lambda serverless functions. But more recently, they've drastically increased that support to 200 different services, which has come round to quite a positive reception on Twitter, following some of the AWS group there. And that's largely achieved through integration with the AWS SDKs. The step functions themselves can scale to process thousands of different requests or execution starts per second, depending on the mode, but for each of those modes, it is a scale in the thousands, so can handle quite large volumes of traffic. And much like many serverless technologies, you're charged for what you use. So the pricing does depend on the mode again, which I'll touch on in more detail later, but ultimately you're just charged for when requests are being handled by your system. So moving on into using step functions, if we were to open the AWS console, you can be presented with something like this snippet of the Graph Inspector. The Graph Inspector gives you a visualization of what your workflow looks like with the start and end states mentioned before, and it can give you a breakdown for each individual step, what was successful, what failed, what's perhaps still in progress if it's a long-running process. It just gives you a nice out-of-the-box visualization of what's going on. And if you have a lot of different requests in iteration and in process, then this is a really good way to quickly identify what's working and what's unsuccessful. You could dive deeper into that, and for each individual box, you can see how the data looks going into your step and how the data looks coming out. And that's what's provided in the step input and step output tabs, along with a details tab, which can give you information like, is your task invoking a Lambda function, or is it sending a message to an SQS queue? And in the case of Lambda, it can also give you links direct to the logs, so you can see the execution details. And this can be a particularly valuable and worthwhile experience if you're trying to debug something unexpected within the flow. I think the only other thing to perhaps point out at this time is there is an export functionality on the top right corner, and this could be particularly useful for just quickly exporting a PNG, which you can then add to slides for perhaps stakeholder meetings or sharing with customers, other use cases, just to quickly show what's going on with any given system. Now, some parts are blocked out just because they're including some certain company names, so it's just more generic structure I'm sharing with you now. Beneath the Graph Inspector, we have an execution event history. And this can give you a breakdown with different timestamps of when your execution begins, when it terminates, and when the individual steps or tasks are processing. And if you do have it, for instance, hooked up to a Lambda function, then you can have links to the Lambda and the CloudWatch logs, just like the details tab before. The only caveat I put here is, whilst the event history can be very useful for debugging, if you have lots of different iterations or lots of different steps, this can very quickly grow unwieldy and quite difficult to navigate. So that's the only caveat I put here, but for smaller workflows, this is a particularly useful breakdown of what's going on in any individual request traversing your system. In terms of defining step functions, there's a few different ways to go about doing this. More recently, Amazon have introduced what's called the Workflow Studio UI, and this is effectively a way to avoid as much programming as possible in terms of defining your workflows with some drag and drop features. And the snippet I'm sharing from the AWS blog on the right side there, where you can just see different things like a DynamoDB put item for writing records, or SNS publish to broadcast messages to different services. And you could just play around with the UI there to formulate how your processes will look. More traditionally, people will typically program state machines using a custom language called the Amazon State Language, which shares a lot of familiarity with JSON. And this can be persisted to AWS CloudFormation templates. So if you're using infrastructure as code, you can persist these definitions into what is Amazon's infrastructure as code solution, CloudFormation, in either JSON or YAML. You can go a step further and adopt higher level constructs like the AWS Cloud Development Kit, the CDK, which gives many more higher level ways of formulating the same definitions, which are then transformed into CloudFormation templates under the hood. Now, if we stick to CloudFormation for this example, this is kind of how a definition would look if you had it in a YAML template. So we define a state machine, and it'll have a collection of different properties. So we can give it a name, we can give it a type, which is the state machine mode, in this case, standard. And then we provide the definition string, which is effectively a long string in this instance. And you will have a list of states, and each one will have a task of a particular type. And there's a range of different types, most of which we'll cover in the next hour. But you've got things like a choice, where you can indicate a particular path based on how your data is looking, or if fail state to terminate your flow, or parallel for fixed branching. There's many more there. There's also input and result paths. So this can give you an indication of which parts of your data payloads you want to give to a particular task. So you don't have to feed a whole JSON object to a task. You can specify a particular snippet by key. And this is done through JSON path support. So JSON path effectively uses a $sign to indicate the root of your payload. And then you can add key names to access nested values or nested lists, and just specify those specific subsections of payloads that you want a task to process. The only other thing to add would be retry functionality, which we'll touch on in further detail later, but step functions does give that out of the box. So with a sort of quick overview on how step functions are looking and why you may use them, the first case I want to touch on is an ETL pipeline, which is a fairly common use case, I think, for step functions, where you want to take data from one or a couple different data sources, perhaps do some transformation on that data, and then load it into a target site. In this particular instance, we're going to be talking about taking financial data from a third-party billing platform. And we have teams of analysts and finance who would like to gather insight from the data that's currently stored on that platform. So we're going to establish a regular sync, which will take the data from the billing platform and store that in an internal data warehousing solution. We could start off with an individual Lambda function, very primitive, just querying billing platform, fetching some data, writing that into the data warehouse, which we can take as Amazon Redshift cluster in this instance. Now, caveat here is that Lambda functions, like many serverless functions, are capped to a certain time frame, and for Lambda, that is 15 minutes. And going a couple of years back, it was only 5 minutes. So the increase to 15 is good, but nonetheless, still a fairly big constraint for an individual function to be handling, especially if we want to retrieve vast volumes of data. So the other problem we also face is the billing platform is using an API which returns data asynchronously. So it's not going to fetch the data immediately for us. We cannot guarantee that we will have everything we need within the 15-minute time interval. We need to be a little more sophisticated in how we're doing this data querying and data retrieval before loading it into our data warehouse. So we need to do some sort of polling mechanism. And we can perhaps configure a choice state in this instance where we can decide what to do next in our workflows based on the response given to us by the billing platform. So we invoke a query to the billing platform. It will come back with a status indicating whether a query is processing or done. And we can save that in our result path into the payload for our workflows, into our state machines, and use that status to then decide whether we go to the second choice, or sorry, the first choice, the second state, or the third choice. And they've got a sort of example snippet on the right-hand side, whereby we are using a variable called status to achieve this. If it equals processing, we want to go to another state in a workflow called wait 30 seconds, fairly self-explanatory on what that one's doing. But otherwise, if the status is done, then we'll go to a state called end iterator. in this case. So the state names in this case are not strictly relevant, but more just to demonstrate how you reference different variables and what values they equal before deciding what steps next to use in your workflow. Visualizing that, we've got a few different things going on now. And if we have a few different Lambda functions, this is where an opportunity for step functions may come into play. So we can have one function that will request the data from our billing platform that will invoke the query. We can have a second one that will then poll the platform and see whether the query is processing or done. If it's processing, we'll go into a wait state for 30 seconds or for a little while longer before retrying the poll. Otherwise, if we get a status done back from the billing platform, we know we have the data and we can jump straight to a third function, which will sync our financial data into the Redshift data warehouse. So a few different things going on at this point, but by having the logic distributed across different functions, we no longer need to concern ourselves with the 15-minute cap, and we can replay this poll effectively up to a year under standard mode of step functions. That's how long an execution can last. Again, with different modes, there's different constraints, but on the standard flavor, it can be up to 1 year. So plenty of flexibility there. Now, the way this particular API for the billing platform worked is that we had to invoke a separate query for each individual type of model we wanted to sync. Now, this platform is hosting things like payment transactions, things like accounts, invoices, lots of different models that we would want to sync into our data warehouse. And for each one of those, we needed to invoke a separate query and pull those separate queries and wait until they were all done. So this is where we want to add an element of concurrency to our step functions. And we could have a couple of options to achieve that. The first would be a parallel task, which would give us a fixed number of branches that we define within the state language and define within the definition of our workflow. This would give us quite a bit of maintenance overhead, though, if we ever wanted to change which models we were syncing. Perhaps we wanted to add new models or remove some models. This may require us to make some changes to the state language. And in turn, if you're going through a code review process and a testing process, you would have to run through all those different iterations every time you changed the list of models you were syncing. So whilst parallel tasks could work in this instance, it added a bit of extra overhead for teams maintaining and owning these systems going forward. In 2019, an alternative came into play called the map state, which offers something called dynamic parallelism to step functions, whereby you can have a variable number of concurrent executions based on an array in your payload. Taking an example on the right-hand side, we have a key called the items path, and that is referencing something in our payload called base objects. We can think of base objects as a list of strings, which are all the different models we want to sync. And if we want to modify that easily, we could have a step earlier in our workflow, which would dynamically set the base objects list to whatever models we're looking to sync. And we can have how you go about populating that variable in the first place is entirely circumstantial. You could just have some logic in a Lambda function, or maybe it's fetching things from an external store. But ultimately, as long as your list is defined in the payload, and in this case, it's called base objects, then that dictates how many concurrent executions you want, or how many executions in total you want, rather. You can cap the concurrency, that is optional. Theoretically, you don't need to do this, and it can run as many different elements in your list as you like. But if for whatever reason you do need to constrain the concurrency limit, there is a max concurrency field, which in this example is set to 30, just to give you that upper cap there. And much like the input path and result path I was showing before, the items path is using JSON path syntax as well. So it doesn't change a huge amount visually, other than what's under the peripheral or the box with the lines is just repeated iterations. So we can have an extra Lambda function at the start for invoking all the different iterations and populating the base objects list that we're looking to use in our payload. And then it's the same process as before, querying or running all the different queries on the billing platform, polling all these different queries, waiting until they're all finished, and then syncing all the data we've retrieved into our data warehouse. But then we're presented with a different problem, whereby the payloads can only be up to 256 kilobits. So fairly small constraint. And whilst that may be useful in many cases where we're processing small requests, in our case, we could be retrieving vast volumes of data from our billing platform and certainly going way above the 256 limit imposed on us. So how we go about that would require us to add an extra element to our platform. And a second concern would be that the data is also holding a lot of sensitive PII, or personally identifiable information. So it'll have customer names and other customer details related to their finances, which we don't want exposed to everyone with access to the AWS console. Ideally, we want to lock that down and keep it to a minimum number of eyes and still allow all engineers access to the AWS console to debug issues with the workflows. And it was pretty difficult to hide just the specific step input and step output tabs whilst keeping the rest of the console open. It was very much a case of blocking all access to the step functions console or allowing all access. And that wasn't necessarily desirable if there was going to be sensitive data in the payloads. So with these two constraints in mind, we looked to adopt an additional storage service for our payloads. In this case, we use something called the simple storage service, S3, which is effectively object-based storage. We could populate this bucket or collection of files with JSON-based objects, which will include our accounts and our invoices and our transactions and all the other models we're interested in. And once we've gone through all our different iterations and written all these different objects to our bucket, we can then use the final Lambda function to read from that bucket and write to the data warehouse. You don't necessarily need to use S3. There are other options, perhaps DynamoDB tables with no SQL records, but S3 is the most common example I see for simply taking what is JSON formatted responses from the billing platform in this instance and immediately writing them to a persisted location. I think the only other thing to add at this stage is error handling, which was touched on briefly earlier on. Step functions do out of the box offer automatic back-off retries with configuration, and we can add granularity so that we can have different retry behaviors based on different exceptions that are raised by our tasks. By default, if we were to set some max attempts and a back-off rate, this applies to all different exceptions, but you can set the error equals to indicate you just want specific exceptions to be treated with specific retry configurations. So there might be some exceptions you don't want to retry at all, or some you want to retry more than others, and step functions allows you to have that granularity. Ultimately, retries aren't always going to succeed, so I would still recommend, probably fairly self-explanatory, to set up some alerts and configuration as well, just in case all retries fail, and then some manual remediation can be undertaken. And just for a specific example, using the workflow we've talked about so far, we can say we try to invoke a query for the billing platform. Maybe the billing platform comes back with an internal server error or a 49. We can then hold off for a couple of seconds, retry. If that fails, wait for a little bit longer the next time and try a third time, and so on and so forth until we hit our max number of attempts or max number of retries, and then terminate the workflow entirely. In terms of costs, it varies between AWS regions, but for many of the different regions, including Ireland and US East 1, most people I believe use, we are charged for $0.025 per 1,000 transitions in our workflow. So for each individual step and each individual progression we're making, it takes 1,000 of them before we're charged even a small sum on our workflows. Speaking anecdotally, compared to other serverless services like Lambda and DynamoDB, I tend to find step functions is more expensive, but in the grand scheme of things, it's still been a reasonable budget and not been too much of a source of concern in my experience. But just to give a rough indicator there. The retries do count as state transitions, so bear in mind the more retries you configure, the more that may add to your bill. And be particularly mindful of this if you were to use parallel fixed branching or the dynamic map parallelism. So I think the key highlights I wanted to take away from this particular example are the parallel branching, the map dynamic parallelism for concurrency. The large and sensitive payloads consider using external services to store that data between steps, like the simple storage service or DynamoDB, and take advantage of the error handling with the costs in mind, but nonetheless to automatically remediate problems and reduce the amount of manual interventions required on the step functions workflows. Now, I'm happy to take a quick break point here if there's any questions, Carol, at this point, just one or two of them perhaps before we move on.
So I've not actually got any questions yet, but it's a good chance for folks to put any in the chat. We'll give it, it's in a little bit of a delay, so we'll give it a few seconds for folks to put any questions in. We've not had any yet.
No, it's quite okay. If there's no questions now, I'm happy to crack on and we could just take them at the end.
Yeah, I think that's fine. We'll wait and see if we've got any, and we'll keep them for the end then. But if any do come in later, I'll just jump in and interrupt you.
That sounds good, no trouble, thank you. Okay, so we come on to the second use case. The first one broadly touched on having a small number of requests, but each request would be fairly large in scale in terms of the data we'd be passing between states and in terms of what we were processing toward the end for the data warehouse. This one's kind of flipping that on its head, and we're going to be dealing with requests that are relatively small payloads, but there will be very high volumes of traffic and high volumes of requests coming through. So it's scaling in a different respect here. Instead of individual payload sizes, this is just the sheer volume of payloads. Now, in this instance, we can stick to the sort of financial billing platform theme, and we want to start charging or invoicing customers using an external API. And we're expecting tremendously large volumes of requests to come in spikes for this. It's not going to be a constant workflow or persistent workflow. It's very much going to be the occasional large jump in traffic before it then settles down again. In this instance, given the financial nature of what we're working with, it's fairly critical to us that we don't accidentally duplicate requests or double charge people. And so that's going to be an important aspect in a lot of the problems we face for the second part, or the second use case. We can start again with an individual Lambda function. We have the same concerns as before with the 15-minute runtime. But all we're doing in this case is submitting a request, billing platform will come back. It'll either say it was successful or failed, and then we can decide what we want to do downstream logic based on that response. However, the billing endpoint does impose rate limiting, and Lambda function theoretically can scale seamlessly, horizontally, to any number of concurrent executions. There are account-wide limits, but they're fairly high. So, excuse me, the billing endpoint rate limiting is a concern, and we need to find a way to enforce a limited concurrency and allow our requests to, even if they're arriving in large spikes of traffic, still be handled gracefully at a sensible rate for the external API. So how do we avoid throttling in this instance, and how do we manage this discrepancy in scaling capabilities? The natural answer would perhaps be to consider a queue. So we can sort of split out some of our Lambda function logic, and we will have perhaps one step to transform data for what we want in our API payload or API request body. There's no reason to limit that concurrency. That can go scale as much as we like. We can pop the messages into a queue in the format ready for the API submission, and have a Lambda function afterward, which will pull the queue, fetch requests, and ship those off to the billing platform. And this is the one where we want to start capping the concurrency and make sure we match the limitations of the external platform. And you can imagine with the different functions in the queue and perhaps some extra steps before and after all this, this would be a good opportunity for step functions. And it's a common pattern I've seen to have functions and queues all forming part of a workflow. So this is sort of adding an element of asynchronicity to our workflow, where in the previous example, the asynchronous nature was derived from the external API. We're now introducing this ourselves with the introduction of a queue to the workflow. So this is something that we have architected and we now need to manage in our step functions. Ultimately, there's a couple of ways we can go about addressing asynchronous tasks. And I think back in 2018 or early 2019, if I can get my dates right, we first looked at a solution called step functions activities. So to give a high level on what step functions activities are, they are pull-based models where we have workers. In this instance, we can think of the worker as a Lambda function, but it can effectively be anything that runs code. And we also have task tokens. So as part of our step functions workflow, we can have a step that will invoke an activity task. And in invoking an activity task, we create a task token, which our worker or Lambda function can pull, retrieve, process, and then report a status back asynchronously. The step function's execution will pause at the activity task invocation stage until the token is returned with an outcome or the activity times out altogether. So there's a few different API interactions there. The worker will be polling the step functions API for a task token. When it finds one, it will do whatever downstream magic it needs to perform. And then it will report back to the step functions API saying, yes, I successfully completed my work, or no, something went wrong and I need to report a failure back to you. So it adds a bit of complexity to our original model. The queue isn't strictly necessary for activity tasks, but in this particular instance, we would use that and pop messages in the queue to warm up the activity worker. So given that the traffic was arriving in spikes and we didn't need to have this worker running 24/7, the queue was a nice way to sort of kickstart the Lambda and invoke it and say, hey, start polling for activity tasks. They're about to come your way. So sort of two things going on concurrently. Transformation Lambda does this data manipulation and prepares it for the API request body. Message goes out to the queue, whilst we also simultaneously invoke an activity task. The activity state or invoke activity state will pause whilst our message is consumed from our queue. The activity worker or the invoice request Lambda will read the message on the queue, know it's ready to pull the activity for tasks, fetch a task, do its work for the billing platform, report the outcome, and then the invoke activity task can proceed based on whether it was successful or failed. So that's kind of the invoke activity step is the bit dealing with the asynchronous nature of our workflow now. But in practice, we found using activities They were very reliable for low throughput, but as soon as we were doing load testing for, say, hundreds of thousands or even millions of different requests, we started to have some issues with a very, very small number of the tokens coming to us. Some of them were either misplaced or mismatched, and we were just generally finding activities were not hugely reliable for high throughput. And given the financial nature of this problem and how it was essential to us, every request was processed at most once, and we were able to reliably handle failures. Losing some tokens or mismatching some tokens and in turn mismatching requests was not sufficient for our needs. So we needed a more robust solution. And round about the time we first faced this in 2019, there was what I'm calling the timely arrival of callbacks. Callbacks were announced in May 2019, and they are providing an alternative solution to address asynchronous tasks in your workflows. Very similar to activities, they use the concept of workers and task tokens. But instead of having a polling mechanism in the worker to fetch tokens, callbacks will push those tokens out. So it simplifies the process just a little for us in this case, where we still have the queue. And in this case, we'll do the data transformation. We will have an invoke callback task, very similar to the invoke activity one before. The token is pushed straight into the queue, and then our invoice request lambda will pull the queue as before or consume from the queue as before, and it immediately has the task token to hand, along with any input data to process. Similar to activities, when the invoice request lambda has done its work and it's submitted a request to the billing platform, the outcome sent straight back to the invoke callback step. And in practice, we found even scaling to hundreds of thousands and millions of different requests in a short time frame, this was a reliable mechanism and all of our task tokens were accounted for. So it was dealing with the task throughput considerably better. But now with the queue, we have an additional problem in that it is possible the queue itself will generate duplicate requests for us. And given this is involving invoicing customers or charging customers, it's essential for us that we don't duplicate those requests. Ultimately, it could give us reputational damage, and it would look bad if we were to try and double charge people. So it's very much in our interest to avoid that and make sure things are processed at most once. To sort of explain why that may happen with queues, the way the simple queue service or the SQS service works is it stores data redundantly in multiple different servers. So we can imagine there's 3 servers here, and let's say the middle one goes offline. The other 2 are still churning away quite happily, acknowledging when new messages are received in the queue and when messages are popped off the queue and consumed. The offline server starts to quickly become stale and loses track of which messages still need to be processed. As soon as that one comes back online, it may well resend a message that one of its sister servers had already handled. And unknowing to the offline server or the previously offline server, that message was already processed. So that's where the duplication may come in. And that is common with what's called the standard mode of queue. So how do we go about resolving this? There's a couple of options. Some may say you can use a different variant of SQS, which is called FIFO, the first in, first out model. This does include deduplication mechanisms. But quite often people will architect queues with Lambda functions using something called the event mapper, which is a way of effectively pushing messages from a queue to a function instead of having the function poll. And this event mapper loses the deduplication guarantee. You could instead have the Lambda function poll the FIFO queue, and for many cases that will suffice. It does mean you'll probably be keeping the Lambda function warm for periods of time where it doesn't need to be warm, but for many cases that would suffice. Alternatively, usually what I see done for many reasons, not just a case of resolving duplication issues, would be to provision a database, DynamoDB for instance. It is extra infrastructure to maintain, but quite often it could be good for auditing or ledging different requests and keeping track of how things are entering different states and how far they progress through different workflows. So it provides a history of what's going on, especially if you need to debug requests and debug workflows. There's a lot of added value to having a database to tracking your data. That's one of the topics I touch on my Medium blog posts. So I will share the handle again at the end if people want to dive deeper into the deduplication strategies. Although it's not directly relevant to step functions, it is a problem I think quite often comes up, and it is one that was quite interesting to write about. So more detail online on that one, but I won't dive into that one any further for the purposes of this talk. So I think the highlights for the second example for me are mostly around the asynchronous activities and callbacks. Activities are good for low throughput, but if you're expecting large volumes of traffic or spikes in traffic, callbacks are a more reliable solution. And I did reach out after writing a blog post recently on activities and received some responses from AWS workers around activities. And often the advice would be, instead of using activities, especially if you need to have decoupled workers detached from your step functions, notifications, and the push-based model isn't easily possible for you, you can just have a callback with messages pushed onto an SQS queue and use a decoupled worker to pull the SQS queue independently of the step function execution. And I think the SQS API seems to handle the higher throughput much more reliably, than the activities API. Now, the other highlight being the request duplication from queues. That can be managed with FIFO queues or databases potentially. And I'm sure there's other options out there, but those are the two different approaches I've seen in my time. To touch lastly on the different modes, I've talked throughout so far on what's called the standard mode of step functions. There is an alternative one that came out in, I think it was late 2020, if I remember right, which is called the express mode. And if you're working with strictly synchronous workflows or synchronous processes, express may be the answer for you. To give a quick comparison on the two, a standard one, as I mentioned before, can run for a full year, whereas the express can only go for 5 minutes, so a considerably shorter time frame. For delivery mechanisms, standard is at most once, so either successfully send one execution for a request or not send it at all. Whereas express can send multiple copies of a request. So we've got the same issue with express as we did with the simple queue service, in that you have an at least once model and duplicates are possible. So something to bear in mind on that front. With the express mode, you also have a 5-fold increase in your execution starts from 2,000 to 10,000, and AWS quota is being nearly unlimited transitions for the express mode, whereas we're capped on the standard one to 4,000 per second. I think express originally is very much tailored toward IoT contexts or high data streaming contexts. That's where I think its main selling points are. So short-lived, synchronous, high-volume processes is very much its selling point. The caveat to add to the express workflow is you lose the visualizations that I showed at the start of the presentation. So the graph inspector visualizations, they are not available, or at least were not available last time I worked with express step functions. So you're relying very heavily on CloudWatch logs to debug and inspect the behavior of your flows. And if you have large volumes of data plowing through your workflow, then in turn you will be generating a lot of logs, and that can be quite difficult to manage. So that's the caveat I'd put to express. But nonetheless, in terms of costs, Express does show, I can only speak anecdotally, I don't have set figures to hand, but Express did show a notable dip when we did a migration from standard to Express step functions in terms of how much we were charged. The standard model is charging per state transition, including the retries I've touched on before, but the Express mode is based on number of requests and their duration, and the durations being at most 5 minutes. So if Express fits your needs and you're happy with the caveat that you will be relying on logs rather than visualizations for seeing how workflows perform, then yeah, you can see a notable cost reduction going down that avenue. Now, I think before I wrap up, I should add a note that Trustpilot, where I work now, is hiring. We are hiring in Edinburgh, in Copenhagen, Vilnius in Lithuania, and other sites as well. And we've got things across full stack engineering, staff engineering. We do have things on the management track as well, like engineering managers. Plenty of opportunities out there. So if you're in interest of a new opportunity in engineering down the individual contributor path or the management path, then we have open positions online on our website. You can just search for Trustpilot vacancies or reach out to me directly, and I'll be happy to put you in touch with someone from our talent acquisition team. So I think that brings me to a wrap. If there are any questions at this stage, Carol.
We do have a question. We've got a question from Steve, which I'll show on the screen just now, but it says, are there any APIs or CloudWatch entries to track things like how many step functions are in state X or how many failures have been encountered?
That's a good question. So you can definitely gain that sort of granularity of logs. So I think that's an optional feature, but you can enable CloudWatch logging. And in the Express mode, it's particularly valuable when you don't have the visualizations to hand. So you can definitely have a way of extracting all the different logs showing when you've entered a specific state or how many have failed. I think, does that answer the question?
I think so. I think so. Steve can let us know. And yep. I've just put in the chat there asking if there's any more questions for anyone, from anyone, sorry. But I guess one for me is, and it's always a good one when it's new technology, or it's at least new to me, how would you get started if someone's like really excited about step functions now after seeing the talk? How would you recommend people go and learn more?
It's a good question, and there's multiple different ways to go about it. I think, speaking from my own experience, the AWS study material and certifications were a great way to accelerate and learn not just step functions, but everything AWS. So for me, 3 years ago, I was on a pretty rapid learning path on all the serverless technologies, from Lambda, DynamoDB, step functions, and much of what I've touched on today. So yeah, I would say look into the different AWS studying materials and certifications if you're interested in getting those. Cloud Guru is another platform that can be quite good for tutorials and workshops. Udemy does a lot of courses too, I believe. So Udemy charges, as does Cloud Guru, I think. But yeah, plenty of training resource there. Blog posts in terms of diving into specific topics are pretty valuable. And ultimately, I think the best thing as well is just to try it out. So you can have a free trial account or a cheaper tier account with AWS if you're just signing up for the first time. And I would say just give it a whirl, try it out, see for yourself what works and what doesn't. I find that's one of the best ways of learning.
Awesome. Yeah, just jump in and try it. It's basically always my option. Have a little side project or a wee idea in your head that you want to build and just go for it.
Yep.
And what is there a typical use case? I know that's a very vague question, but is there any like use cases that are like perfect for step functions?
I think ETL pipelines is definitely the most common one I've seen, and that was why I was pretty keen to use that as one example in today's slides. What else? Yeah, really, step functions always enter the conversation for me when we have lots of different microservices and we want to process coordinate them together. It's a fairly generic answer, but yeah, things in finance in particular have been my use cases, but I'm sure that can scale to all sorts of different domains. And for a more concrete answer, ETL pipelines for me.
Awesome. And I'll just wait and see if we've got any more questions. Steve's confirmed you have answered the question. That's great.
Awesome.
And I guess so. You mentioned a few times in your talk, like as you've been learning or as you've been using, there's been new features that's been brought out. I think like callbacks was one of them, and a few others. So, how do you keep up to date with? It's one of those things that's always developing and always moving. How do you keep up to date with the latest and greatest?
Yeah, you're absolutely right to say a lot of features have come out in my time using it. So to give a bit of background before I answer the question, step functions were launched in 2016. I started using them in 2018, and particularly in 2019 and 2020, a lot of new significant features have come out. And even recently, with the support for 200 services now instead of 17, has been a big win. It sounds like AWS is investing a lot of time into that. In terms of how I keep in track on that, there's a few different answers. They do have a very good Twitter presence. So if you can find AWS Step Functions team on Twitter, Dan, I don't want to quote his name in case I got it wrong. I think it's Dan Ronald is the name of the product manager for the Step Functions. He quite often will share a lot of news and a lot of announcements for Step Functions, which is great. There's the AWS blog, and there are tags for Step Functions in particular, which can be quite useful to follow you. AWS also does an annual conference called reInvent, which is usually November, December time, and there's always announcements then. So it's worth keeping an eye on the reInvent pages and ideally signing up to the conference too, because I think the last few have been online. I suspect this one this year might be in person, but I'm not too sure off the top of my head.
Real life conferences and meetups, those are the days.
Wild.
Hopefully we'll have at some point this year we can have a real life Scottish developers meetup. Here's hoping. Every time we think that we might organise one, things happen. So yeah, we'll stay virtual for now, at least for the next few.
It's looking optimistic so far. Things are calming down and going in the right direction. So hopefully,
here's hoping, and then we can decide. Okay, what city do we want to have the first in-person Scottish developers meet up for years? That would be a good problem to have. Here's hoping we have that problem soon. But we'll give it a few more seconds to see if there's any more questions. But thank you, Ross, for the talk. It's like we've really detailed, and you can tell a lot of effort into that. So thank you so much.
No trouble, thank you, and appreciate the opportunity to speak, of course. I know Andrew reached out a while ago and very much appreciate this opportunity to, speak about something that I'm very passionate about and I've quite enjoyed working with.
Awesome, and yeah, look forward to hearing more about it soon. Oh, we've got one question before we go. Steve, again, thanks, Steve. So if you had a Lambda integrated with SQS that was experiencing timeouts, but does ultimately complete after some retries, do you recommend moving to step functions or stick with the timeout and retry option within Lambda? And then the second part, it says where the move to step functions would implement a loop/batch sort of pattern.
I wouldn't say I would necessarily jump to step functions for that particular example if it's just one queue and one Lambda. I think if you had other elements at play there with like additional Lambda functions on the other end of the queue or other resources you're coordinating, I usually follow a rule of three for pretty much anything I'm working on with. And in this instance, if there's only a couple of resources you're managing, I think step functions would cost too much for the benefit they're giving you.
I think that's fair. It's a Really good question, actually, because that's the bit that's always, and I'm mostly working Azure rather than AWS, but there's always that thing where there's like similar-ish products, and you're like, what scenario should I use which for? So it's always good to have a specific use case to talk through.
It's always a hard choice, I think, with anything, any project, exploring what solutions work and whether step functions is the right one. It can be quite an interesting debate, and yeah, it's good to see what's out there. And step functions, like touching on one of your second question, I think, about the different features, it changes all the time. So every time step functions is explored as a particular solution or potential candidate for a solution, it's always good to dive deep and work out the finer details.
Awesome. No, that's great. Thank you so much again. And thanks for folks who've joined us. We've had people in the comments from sunny South Lanarkshire. I don't know if I believe how sunny it is. And someone all the way from Poland. So I think they won our furthest travel virtual attendee. So thanks everyone for joining us. And if there's no more questions, I guess it's just again, thank you, Ross, for joining us and spending your evening presenting to us. And thanks for everyone for joining us. Sign up on meetup.com. As I said, we've got the 2 sessions that are coming up, March, then April. And if you'd like to talk to us and to let us know what you've been working on, then do get in touch. We're always looking for speakers, and even if it's a lightning talk or if you're a new speaker or you'd like to run a workshop, whatever it is, like, give us a shout and we'll be more than happy to accommodate you.
Awesome, and thank you very much again for giving me the time to talk today and for everyone tuning in.
Thank you. Cheers, everyone. Well, goodbye.
Bye for now.